Let's find a confidence interval in SPSS, then we'll find the same confidence interval in Excel. You turn to page 145 or so in your course packet, take a look at problem 3. Now problem 3 reads that we have a bakery and we produce loaves of bread with 1 pound written on the label. We also have a random sample, so random samples are fairly important. It's one of the technical requirements of finding a confidence interval. You need a random sample from your population. So we've got a nice random sample from today's production, and here are the values. We've observed these 12 values. We're asked to then find a 95% confidence interval for the mean weight of all loaves produced today. So I've typed in these 12 values into SPSS. So if we go over here, you'll see that I've typed them in, and I've decided to call the variable weight, although whatever what you call it is really not that important. To find 95% confidence intervals in SPSS, we're going to use a function under Analyze. So Analyze Descriptives, then Explore. Let me reset this. Using this is very simple. We just copy weight into the dependent variable list, then hit OK. Now, the first thing that you want to note about this data set is that your sample size is very small. It's only 12 cases. Now, when you only have 12 cases, it's very important to pay attention to the assumption of the t-distribution, namely that you've sampled from a normal population. So if you don't have a normal population, you can point to the central limit theorem. You can rely on the central limit theorem to enable you to find confidence intervals, but only when the sample size is sufficiently large. And that what sufficiently large depends on is how skewed is the distribution, whether there's outliers and so forth. And 12 cases just isn't very much. So you have a hard time pointing to the central limit theorem in this case. Therefore, you really need to have normal data. So the very first thing you should do is go look at a box plot and see if the data are roughly normal. And in this case, they are. So you don't have any horrible skewness here. You don't have any nasty outliers. We can safely assume that this is a normal distribution. Now, having checked normality, we go back to our descriptives box, and you're going to see that in the second row we have a 95% confidence interval for the mean that extends from 0.998 to 1.045. So that's our answer. The 95% confidence interval is 0.998 to 1.045. And we're done. Now, sometimes you're going to have to find these in Excel. So let's duplicate what we just did in Excel. And so I've typed in the same 12 numbers here. I put them into column B. This allows me some space to type in some labels. So the first step to finding a 95% confidence interval for the mean is to find the sample mean. Let's call that x bar. We call it the sample mean. And the sample mean is just found with the average function. So we'll type in average, and I'll go highlight my 12 numbers, close the parentheses, and it looks like I did something wrong here. Let's go back to this. Average, and then I'll highlight my 12 numbers, so B1 through B12, close the parentheses. You're going to hit enter. And we get the average as 1.0216 something or other. And if we go back to SPSS, you'll see that's exactly what it found to be the mean. Now, the next thing we need to do is to find the standard deviation. So the symbol for this is just S. Sometimes I call it S sub x. And S is going to be STDEV. And you want .s. Now the .s stands for a sample standard deviation. So I'll open the parenthesis, I'll go highlight my 12 numbers, close the parenthesis, and I get 0.03713. If you go back to SPSS, that's what appears here in the standard deviation row, 3713. Now the next thing that we should find is the standard error. So the standard error is just the standard deviation divided by the square root of n. So the standard deviation is cell B14, and we're going to divide by that by the square root of n, which in this case is 12. Go ahead, enter, and you get 0.0107. And if we go back to SPSS, you're going to find the standard error is sitting up here, 0.01072. And you'll see there's also a 2 if you round down here. Now, to find the confidence interval, we're going to take the sample mean plus or minus the standard error times a t statistic. Now, when your n's are big, say above 30-ish, the t statistic is going to be around 2, 1.96 to 2-ish. But when the sample size is small, t is going to be a bit bigger. Let's just find that t statistic, or let's call it the t value. So the t value can be found with the t inverse function. Now you have to give it a probability. So this probability says how much area do you want in the tails. So let's put 5% in there. That's going to give us a 95% in the middle, 5% in the tails. Then we need the degrees of freedom. The degrees of freedom are always just the number of cases minus 1, so it's 11. Now this number ought to be around 2, a little bit bigger though, because our sample size is quite small, and so it's 2.2. Now let's get our upper end of the 95% confidence interval. That's going to be the sample mean, so B13, pardon me, plus the standard error times the t statistic. And let's go check SPSS, so 1.0452 something or other. And there you go, you get the exact same number here in SPSS. The lower end is going to be equal to the sample mean minus the standard error times the t value. And so you get 0.9981 if you round. And sure enough, you get 0.9981. And we get exactly the same thing as we got in SPSS. So all that work in Excel kind of makes you appreciate SPSS because it does everything for you. And we didn't even bother checking for normality here in Excel. We'd have to use an add-in to get a histogram. So SPSS is much easier. So that's how you find a confidence interval.